Welcome to EMR Physics. I am Raju, NCERT 12th Physics. We are solving the numerical problems given in Chapter 9 Moving Charges and Magnetism. In this video, we are going to see how to solve the book bag problem 4.13. Problem is subdivision A. A circular coil of 30 turns and radius 8.0 cm carrying a current of 6.0 ampere is suspended vertically in a uniform horizontal magnetic field of magnitude 1.0 Tesla. The field lines make an angle of 60 degree with the normal of the coil. Calculate the magnitude of the counter torque that must be applied to prevent the coil from turning. Subdivision B. Would your answer change if the circular coil in subdivision A were replaced by a planar coil of some irregular shape that encloses the same area? All the other particulars are also unaltered. So this is a given problem. Now let us see what are the numerical data given in this problem. Number of turns is given, which is 30. Radius is 8.0 centimeter. Current is 6.0 ampere. A coil is suspended vertically in a magnetic field. Magnitude of the magnetic field is 1.0 Tesla. Angle is 60 degree. This is the angle between magnetic field and area vector. What is asked? We have to find the counter torque that must be applied to prevent the coil from turning. That is, when a coil is suspended in a magnetic field, it experiences a torque. Because of this torque, the coil is turning. To prevent the coil from turning, we have to apply the counter torque, and it is asked to find the magnitude of the counter torque. In the second subdivision, it is given that circular coil is replaced by a planar coil of some irregular shape, and it is given that the area of the circular coil and the planar coil are same, and also it is given that all other particulars are unaltered. What is asked? We have to find whether the answer will change or not, that is, whether the counter torque will change or not. Now let us see how to solve this problem. Now let us write what are the data given in this problem. Number of turns is given, n is equal to 30. Radius of the circular coil is given, r is equal to 8.0 centimeter. This has to be converted to SI unit meter. This is equal to 8 into 10 to the power minus 2 meter. From this we can find the area of the circular coil. Area A is equal to, since the coil is circular, area is given by pi r square. Pi is 3.14. We are taking pi as 3.14 into r square. R is 8 into 10 to the power minus 2 meter. R square is 8 into 10 to the power minus 2 whole square. So this is the area of the circular coil. Next, what is given? Current passing through the circular coil is given, which is I. I is equal to 6 ampere. Next, magnitude of magnetic field is given. B is equal to 1 Tesla. And theta is equal to 60 degree. What is asked? We have to find the counter torque to prevent the coil from turning. When a coil is suspended in a magnetic field, it experiences a torque. So if we know the torque experienced by the coil, the same will be the counter torque that must be applied to prevent the coil from turning. So torque experienced by the coil will be equal to counter torque. Both are same, but this has to be applied in the opposite direction to prevent the coil from turning. So torque is equal to N B I A sin theta. This is the formula we are going to use to calculate the counter torque. We know the value of N B I A theta. Therefore, we can calculate torque. This is equal to N is 30, B is 1 Tesla, I is 6 ampere, area is 3.14 into 8 into 10 to the power minus 2 whole square into sin theta is 60 degree. Sin 60 is equal to root 3 by 2. Root 3 is 1.732. So this is root 3. So if we substitute all these values, we can get torque is equal to 3.13 Newton meter. Newton meter is the unit of torque. This is the torque experienced by the coil. The same will be the counter torque that must be applied to prevent the coil from turning. So this is the answer for the first subdivision. What is asked in the subdivision B? Circular coil is replaced by a planar coil of same area, but the shape is irregular. From this relation, we can say that torque is proportional to area. If n, b, I, theta are same, then torque will be proportional to area. If all other particulars are same, then torque is proportional to area. If the area also same, then the answer will not going to change. This is the answer to the given problem. If this video is useful, please subscribe the channel, share it to your friends. Thank you for watching this video.